Okay, so we're going to talk about radical functions in this unit. So, um, the parent square root function is f of x equals square root of x. And this function we could graph if we made a table. So, x and f of x, which is the same as y. So, one thing we know about square roots is that we can't do the square root of negative numbers. So the square root of negative 1, that's I, which we can't graph. So this gives us an error, right? So then the few values we could easily graph the square root of are 0, because the square root of 0 is 0. 1, because the square root of 1 is 1. 4, because the square root of 4 is 2. And then all the way up to 9, since the square root of 9 is 3. So if I plot those 4 points, then I get 4, 2, 9, 3, and we have our parent square root function. So if you turn this sideways, it actually is going to be half of a parabola, but oriented sideways. So it increases more slowly than a linear function. The domain and range of this function, so the domain is only non-negative x values, so we can't do the square root of anything less than 0. And then the range is only non-negative y values. So then another similar function we could look at this unit is the cube root of x. So when I graph my cube root function, so that's asking what number raised to the third power gives us x. So the cube root of 0 is still 0. And the cube root of 1 is still 1, because 1 to the third makes 1. But then the next number I could evenly do the cube root of is 8. And the cube root of 8 is 2. So all the way up here. So see how this is going to grow even more slowly than the square root function. But one thing to keep in mind about this function is we can actually cube root negative numbers too. The cube root of negative 1 is negative 1. And the cube root of negative 8 is negative 2. Because when you raise a negative number to a odd power, it goes back to negative, right? So negative 2 times negative 2 times negative 2. This part makes positive 4, but then we have times negative 2, so it goes back to a negative number. So we end up with a function that looks like this. So this part of it just looks like a square root function that's going even slower, and then it also goes down this way. So in this function, the domain and the range are both all real numbers. So even though it goes very slowly, so like the next point along here, when we get all the way to x equals 27, then y would equal 3, but it would keep going up very, very slowly. So the transformations rules that we talked about in the first 6 weeks of the year are going to apply to all the functions that we deal with all year. So when we did the transformation rules back in the first 6 weeks, we just looked at if we applied it directly to like f of x notation. So here it says f of x equals square root of 3x minus 12. So this is basically like the square root acts as the entire f, right? And then the parentheses would be whatever's inside of the square root. So this is like having f of 3x minus 12 if f of x was equal to square root of x. Okay, so what we have on this function is x is being multiplied by 3, and we're subtracting 12. But remember, one thing we talked about earlier is whenever we deal with these horizontal transformations, we have to factor out the horizontal shift component. So another way to write this would be 3 times the square root of x minus 4. When we write it like this, we can see that we have a shift right by 4 instead of by 12. and we have a horizontal compress by 1/3. So it's the reciprocal of 3, just like when we did the transformations back in the first 6 weeks. So since I shifted it right 4, then that means my domain, instead of being x greater than 0, is now x is greater than or equal to 4. And my range isn't going to change at all because I didn't do any vertical transformations. Okay, so here we have 5 and then square root of negative x minus 5. Just like on this last one where we have to factor out the 3, here we have to factor out the negative 1. So we have 5 root negative and then x plus 5. So that whatever coefficient is on the x here, even if it's just a negative 1, has to be factored out before we can see the shift. So this is a shift left 5. And a reflection over the y-axis. So because we reflected this over the y-axis, we now have a square root function that is going to, instead of go like this, it's going the opposite direction, right? Because we reflected it over the y-axis. So now it's going this way, and we shifted it left 5. So the domain is x is less than or equal to negative 5, and the range is still y is greater than or equal to 0. So we, oh, and then I forgot to write, so times 5 is a vertical stretch by 5. Now the vertical stretch makes it taller, but it didn't change like the starting location. So compared to the original, our graph is shifted to the left and it's steeper, but it still starts at 0 and then goes up forever. Okay, last one, we have negative 3 times the cube root of 1/2 x minus 2. Again, we have to factor out that 1/2. So we're really going to have negative 3 times the cube root. And I'm going to factor out 1/2, so it means I have 1/2 here. And this is going to be x minus 4. Because if we factor out 1/2 from 2, I have to get the same thing that I started with when I distribute. So if I distribute 1/2 into this parentheses, I would have 1/2 x, and then 1/2 times 4 would give me 2 again. So we have a shift right by 4, and we have a horizontal stretch by 2. And then the vertical transformations, we have reflect over x because it's negative. And we have a vertical stretch by 3. All right, now, since this is a cube root function, the domain and the range were all real numbers when we started, so they're still all real numbers when we finish. All right, so then last, apply the transformations to square root x. So we have reflect over y-axis, shift right 4, and then horizontal stretch by 2. So this means I'm going to make x negative. This means subtract 4 from x. And then this is multiply x by 1/2. So our final result here will be square root of So the order matters here. So if I have reflect over y-axis first, and then shift right 4, then I'm going to do negative x minus 4. So the negative happens, it's going to reflect over the y-axis, and then because I put the x minus 4 in parentheses, it shifts it to the right 4. But because the stretch by 2 happens last, I'm going to put the 1/2 only on the x. If we look at the graph of this, second, exit tablet mode. Yes, so let's go to Desmos and look at this graph. So if I have square root of x, I make it negative. Oops. I make it negative. Then we reflect over the y-axis. If I put the minus 4, but without, or I put the, what did I say? You're shifting to the right, and I put a minus 4, I put a minus 4 inside the square root. It actually shifted it left, which is not what we wanted to do, which is why this part goes in parentheses. But as for the horizontal stretch part, I want a horizontal stretch after I shift, which means every x value on this graph is going to be divided by 2, because we said horizontal stretch by 2. If I put the 1/2 here, I didn't change every x value. I put the 1/2 here, now every x value got changed. So the order of those transformations says I want to reflect it, then I want to shift it, and then I want to stretch it. So I have to write it like this for my final answer. As opposed to, so and then this one, it says shift up 3, and then vertical stretch by 2. So my shift up 3, we know, is add 3 outside. And my vertical stretch by 2 means multiply by 2 outside. All of these are vertical transformations. So I have square root of x plus 3, but because the vertical stretch is going to happen after the shift, I have to multiply that part by 2 also. And then, because my reflection happens after the vertical stretch, I have to make sure that I reflect everything. So outside the parentheses, I'm going to put a negative 2. Again, let's look at the graph to see how that changes things. So if I graph square root of x and plus 3, a vertical stretch means that every x or every y value has to be multiplied by 2. But if I only put the vertical stretch here, now I'm vertically stretching it and then shifting up by 3. And I want to vertically stretch everything. So I multiply this by 2. And yeah, there it is. So every y value got multiplied by 2, including the starting one. And of course, if we distributed, this would be the same as 2 square root x plus 6. So the final result is equivalent to saying we shifted up 6, or we vertically stretched it by 2 and then shifted up 6. It's just the way that the language is written first. Right, and then we want to reflect it, which means I'm going to make the whole thing negative, which then makes it appear as though we shifted down, but again, it's just because of the order that we did the transformations. So if I had only put the negative here, it doesn't reflect it over the x-axis, it reflects it over itself. Whereas this one reflects over the x-axis. So when you're not sure about the order of these transformations, just look at the graphs, right? If the graph is, if the words here say reflect over x-axis last, and your graph is not reflecting over the whole x-axis, then you probably just need to put some parentheses somewhere. With the horizontal ones, everything is backwards still, but it's the same idea. Just ask yourself, am I horizontally stretching at the end or at the beginning, right? Okay, that is all.